In this lesson, we're going to talk about quantum numbers. So there are four quantum numbers that we're going to go through. The first two are the principal quantum number and the angular momentum quantum number. So the principal quantum number describes the average distance of the orbital from the nucleus to the energy level. Okay, so this is going to range from 1 to 7. This corresponds with the periods on the periodic table. So first period is going to have a principal quantum number of 1. Second period, it would be 2, and so forth. The angular momentum quantum number, which is a L, describes the orbital shape. Okay, so on this table here, you'll see that it goes from 0 to 3, S is 0, P is 1, D is 2, F is 3. Okay, the other two numbers that you need to know are the magnetic quantum number, which is M, and then that sub L. That describes how orbitals are oriented in space. So if you know L, the range of the magnetic quantum number is negative L to positive L. And then the last number is the spin quantum number. This describes the electron, the last electron. It describes the direction the electron is spinning. So if it has a spin up, it's going to have a ms value of 1/2, positive 1/2, and if it's spinning down, it's going to have a value of negative 1/2. So let's look at two examples here. It says, determine the quantum numbers for the last electron in the atom of fluorine and then iron. Let's start with fluorine. Okay, so for fluorine, we're going to look at the last electron. The last electron in fluorine is right here in the 2p5 sugar. So let's look at fluorine. The last electron in fluorine takes its home in 2p5. Okay, so let's start with the first number. Our first number comes from the 2. It's in the second energy level. P will give a value, the second number of 1. Okay, so that comes straight from that table. And now let's go ahead and let's draw out the orbitals for 2p5. Okay. So P has 3 orbitals, and we have 5 electrons. 1, 2, 3, 4, 5. Okay. Now, L is 1. So this third number, we're going to number our orbitals from negative 1 to positive 1. Okay, and there will be a 0 in between there. Since this last electron falls in that 0, our third quantum number will be 0. That electron is spinning down, so it's going to have a spin of negative 1/2. Let's look at iron. Iron, we're looking at the last electron, and that's in 3d6. So the first number will be 3. It's in the D shape, so D is 2 according to our table. And then let's go ahead and let's draw out the orbitals. D has 5. There's 6 electrons. 1, 2, 3, 4, 5, 6. And we're just concerned with the last electron, which is right here. Okay, so let's go ahead and number. So we're going from negative 2, as we're looking at the L here, we're going from negative 2 to positive 2. Okay, so it's in that very first one, which is a negative 2. It's spinning down, so it'll have a fourth quantum number of negative 1/2. All right, let's look at two more examples. Let's look at sodium and zirconium. All right, so sodium, it's in the 3s. So the first number will be 3. S, that value that we pull from the table is 0. 3s has 1 orbital, and there's 1 electron. So L in this case is 0. So we just numbered the 1 orbital with a 0. So obviously the third number is going to be 0. And then we're spinning up, so it'll have a fourth quantum number of positive 1/2. Zirconium, 4d. So the first number will be 4. D from that table has a value of 2. When we draw out our orbitals, we have 2 electrons, 1, 2. We're going to number our orbits from -2. Oops, that should be 1. -2 to +2. This last electron is in -1. It's spinning up, so it'll have a fourth quantum number of +1/2. And those are quantum numbers.